Welcome everyone to third day of International E-Conference on Mathematical Advancement and Applications. In this session, our first presenter is Nihal Taş. Her title is the new answer to the Rhodes open problem and the fixed circle problem. We can start if you are ready, Nihal Taş.
Okay, thank you. My name is Nihal Taş. I am a research assistant at Balıkesir University. In this talk, we focus on the two recent open problems. One of these open problems is the Rhodes open problem is related to the discontinuity at fixed point. And second problem is the fixed circle problem. This problem is very new, related to the geometry of the fixed point set of the self-mapping. Firstly, we give a brief history of these open problems. Fixed point theory is very important in the different areas of mathematics, such as applied mathematics, topology, analysis, etc. This theory was started with the Banach contraction principle, but there exist some examples of a self-mapping does not satisfy the Banach contraction principle. On the other hand, they have a fixed point. Therefore, this principle has been generalized using the different techniques. One of these techniques is to generalize the use contractive conditions. For example, these references. In these references, there are a lot of contractive conditions to obtain the fixed point theorems. Another technique is to generalize the use metric spaces. Some of them S-metric spaces, geometric spaces, B-metric spaces. These references is the survey on these techniques. Recently, the geometric properties of fixed points has been investigated as a new generalization of the fixed point theory. These are some basic references. On the other hand, many contractive conditions used in the fixed point theorems require that a self-mapping is continuous at fixed point. But there are some contractive conditions which do not require that the self-mapping to be continuous. In the context, the following open questions raised by Rhodes and Özgür et al. First open question is discontinuity at fixed point such that. Open question 2 related to the geometric properties of fixed points. Fixed circle problem is occur from the open question 2. Many others have investigated new solutions using various approaches to open problem 1. For example, Pant obtained using the first solution using this function and the number m. And so he obtained this theorem. Under the conditions, the self-mapping T has a unique fixed point and T is continuous at Z if and only if the condition is satisfied. After that, various solutions to this problem have been investigated various techniques. There are some references. On the other hand, there exist some applications of the obtained solutions to some other areas, biology, discontinuous neural networks, simulation functions, etc. For example, again, these references. More recently, the fixed circle or fixed disk problem has been studied using some classical fixed point techniques related to the open question 2. For example, Özgür and Taş obtained a solution to this question using the Karistin inequalities. Karistin inequality is this. This theorem is the first solution about the questions. Motivated by this fact, this question has been studied as a geometric approach to the generalization of fixed point theory. For this purpose, some known techniques used in fixed point theorems are adapted to the fixed circle problem on metric spaces and some generalized metric spaces. The fixed circle problem has brought a new light to the fixed point theory and geometric thinking. The contents of this talk are the following. Firstly, we give some solutions to the Rohades open problem using the molecular type, steric type, and charistic type fixed point theorems with a different approach similar to the given approach in these references. Secondly, we investigate some answer to the fixed circle problem using the techniques with three approaches. Finally, we give some consequence of our obtained theoretical results. Now, throughout this talk, we assume that Xt is a complete metric space, T is a self-mapping, and Phi is a lower semi-continuous and bounded below function. In this section, we use the following number n. This number was used in the strict type fixed point theorem. Therefore, we use the strict technicus. In this theorem, at first we define this condition MKCC. MKCC molecular strict charistic. This inequality is related to the molecular type, and the difference is charistic type. The number is strict type. If the self-mapping satisfies the conditions, then the sequence a Cauchy sequence, and that is a limit of this sequence. Also, if T is a key continuous, then T has a fixed point C. Also, T is continuous at the fixed points if and only if the condition is satisfied. Therefore, this theorem is another solution to the open question, and that is Rohades open problem, discontinuity at fixed point. Now, we investigated some solutions, fixed circle problem. Firstly, we defined the number R such that, and the function phi such that the point x is the image of this point distance. In the following theorem, we inspire from the molecular type, strict type, and charistic type fixed points theorem to obtain any fixed circle theorem. Firstly, we recall the notions of the fixed circle and fixed disk. Let Xt be a metric space, the set is a circle, and T a self-mapping. If the condition is satisfied for all the elements of the circle, then the circle is called as the fixed circle of T. Similarly, the set is disk. This disk is called as the fixed disk of the T. Then, this theorem is first solution, and in stock first solutions, fixed circle problem. Let Xt be a metric space, T a self-mapping, R be defined as before, phi defined as the before. If there exists x0 such that the conditions 1 and 2 satisfied, then the point is fixed and the circle, the center of x0 and the radius r is a fixed circle of T. To obtain another fixed circle theorem, we use the formula of the simulation functions. Before the main theorems, we recall the definition of simulation functions. These functions, if satisfies the following conditions, then these functions are said to be as simulation functions. For details, see these references. Using the family, we obtain another fixed circle solutions such that we use the simulation functions, the number n used in the strict type fixed point theory, and these equivalent to molecular type techniques. And we use the Twardowski family, another fixed circle problem. Twardowski defined the family of functions satisfying the three conditions. Some of examples of these families: fx ln x, fx ln x, and some x, and this for details, these references. And using these techniques, Twardowski type, charistic type, strict type, and molecular type, and another solution, fixed circle problem. In the last section, we considered obtained results. We obtained some corollaries. In these corollaries, Rhodes open problems, we use the point x, the distance of the point x and y, instead of the number n. Also, fixed circles results can be considered as the fixed disk results. Therefore, we give the following references using the disk on the metric spaces, such as another fixed disk results under the conditions, and last fixed disk results. Also, the obtained results using the simulation functions can be considered special cases. Special cases for this, we use these simulation functions. For references, main references, Karistin, Sirik, also Karapınar et al. Mirpler, Özgüren Taş, Özgür, Pant. These references are very important as an applications. Twardowski references. Thank you for your attention.
Thank you for a nice talk. Is there any question? I think there is no question. Thank you again, dear
Thank you. Thank you.
And another presenter is Mukaddes Öktem Türeci. Her title speech is Computing Some Eccentricity-Based Topological Indices of Line Graphs of Dutch Windmill Graphs. We can start if you are ready, please.
Yes, thank you. Hi, everybody. First, I would like to thank the organizing committee for this important event. My name is Mukaddes Öktem Türeci. I am studying at Karabük University. Today, I will talk about an application of graph theory in chemistry. The title of my presentation is Computing Some Eccentricity-Based Topological Indices of Line Graph of Dutch Windmill Graph. Firstly, we will give some information. Graph theory has become one of the most powerful mathematical tools in analysis and study of the architecture of a molecular graph or network. The chemical graph theory is an important branch of the graph theory which concerns with mathematical modeling of molecules. It also deals with the study of development of topological indices. A chemical graph is a graph such that each vertex represents an atom of the molecule and represents covalent bonds between atoms by edges of the corresponding vertices. What is the topological indices? A topological index is a numerical value associated with chemical constitution purporting for the correlation of a chemical structure with various physical properties, chemical reactivity or biological activity. Furthermore, topological indices are the molecular structure that describes the structure of chemical compounds, and it helps us predict certain physical chemical properties like boiling point and type of vaporization and stability. The various measures have been defined to measure the robustness of network, and a variety of graph theoretic parameters have been used to derive formulas to calculate network vulnerability. The Winder index is the first topological index in chemistry. Also, it's defined by chemists Harold Weiner. The Weiner index aims to sum of the half distance between every pair of vertices of graph G, and it is defined as, for example, compute the Weiner index of the following star graph K15. Distance every pair of vertices is given as like. Therefore, Weiner index of star graph is equal to 25. The other important topological indices. There are many important topological indices. The degree-based topological indices. We define the degree-based topological indices. The degree of vertex U in G denoted by degree GU, that is the number of the edge which is incident the vertex U. There are many degree-based topological indices. Some of them are given in here. The eccentricity-based topological indices. The distance dg uv between two vertices U and V in G is length of a shortest path between them. The eccentricity value of the vertex U in VG denoted by epsilon GU, that is the large between vertex U and any other vertex V of G. There are many eccentricity-based topological indices. Some of them are given in here. The Dutch-Wanfield graphs, some chemical structure are represented by spatial graph tips. We can find these tips relationship between chemical structure and spatial graph. For example, Dutch-Wanfield graphs that represent Bidante delicans, as can be seen in figure 1. A graph DMN obtained by joining n numbers of cycle graphs CM with a common vertex is known as Dutch-Wanfield graph. The Dutch-Wanfield graph is undirected. We display the graph of examples. The degree-based and eccentricity-based topological indices have been computed in different papers for Dutch-Wanfield graphs. In 2020, the degree-based topological indices have been computed for the line graph of Dutch-Wanfield graph in references to. What is the line graph? Let G be a graph of order n and size m. The line graph of G is the graph whose vertex set is EG and in which two vertices are adjacent if and only if they are adjacent in G. In figure 3, represent the graph G with 6 vertices and 6 edge, and the line graph of G with 6 vertices and 9 edges. Furthermore, we define the line graphs of Dutch-Wanfield graph M equal 6 and 7 in figure 4. In this study, two eccentricity-based topological indices, namely the eccentric connectivity index and the modified eccentric connectivity index, are computed for the line graphs of Dutch-Wanfield graphs. There are many basic results for Dutch-Wanfield graphs in references 3 and 4. The eccentric connectivity and modified eccentric connectivity indices of line graph of Dutch-Wanfield graphs. Let n greater or equal than 6 and greater or equal than 2. First, the two vertices of line graph are partitionated based on degrees of vertices. Sum of degrees of neighbor of vertices, the eccentricity values of vertices and frequency of vertices in line graphs. The vertex partition of line graph with respect to degrees and eccentricity values are shown in table 1 and 2. For both m is even and odd respectively. The tips of vertices of line graph for m is equal 6 is as follows. And generally, the tips of vertices for m is even as follows. In table 2, represent tips of vertices in line graph for m is odd. The tips of vertices of for line graph for m equal 7 is as follows. Generally, the tips of vertices for m is odd is as follows. Using the table 1 and 2, we obtain following theorems. Proof of theorems can be seen in vertex partition of line graph in tables 1 and 2. If we write this value in the formulas of eccentric connectivity and modified eccentric connectivity formulas, we obtain the following result. In case 2, similarly, M is when M is odd, can be obtained as follows. In the main theorems, we consider M is greater or equal than 6. Following tables show that vertex partition of line graphs for M is equal 3, 4, and 5. In figure 9, show the values of eccentric connectivity index of line graph, and in figure 10, show the values of eccentric connectivity index of line graph, and it is clearly eccentric connectivity index of line graph greater than modified eccentric connectivity of line graphs. Conclusion: the computation of different topological indices of various graphical structures offer wide scope for various theoretical studies as well as in numerous applications, particularly in studies of chemical structures and their properties. In this paper, eccentricity-based topological indices of the line graph of a particular graph of class called Dashvenfield graphs have been computed. The values of eccentric connectivity index and modified eccentric connectivity index of Dashvenfield graphs and its line graph have been compared with the three-dimensional graphics. The values of eccentric connectivity index and modified eccentric connectivity index of line graphs of Dashvenfield graphs are greater than values of Dashvenfield graphs. We can say that the line graph of Dashvenfield graphs is more robust than Dashvenfield graphs. In a further study, the different eccentricity-based topological indices can be computed for the line graph of Dashvenfield graphs and references. Thank you for your attention.
Thank you for interesting talk. Is there any question? I think there is no question. Thank you again.
Thank you very much.
Next presenter is Melike Erdoğan. Title of her speech is Evaluating the Smart Campus Key Factors with Multi-Criteria Decision-Making Approach Under Intuitionistic Fuzzy Environment. We can start if you are ready, please.
Okay, I'm ready, thank you. Hi everyone, my name is Melike Erdoğan. I am a research assistant at Düzce University, Department of Industrial Engineering. Today, I'm going to present you about evaluating the smart campus key factors with fuzzy multi-criteria decision-making methodology. This is the flowchart of my presentation. Firstly, I will give you a small introduction about the topic. Then I will talk about the smart campus concept that we adopted along the paper. And I will give the literature background of the paper and the main aim of the paper. Then I will present the proposed methodology with the real case application that we conducted. And I will finish my presentation with conclusions and future suggestions. Before we talk about the smart campus concept, I think we should mention about the smart city concept, which we are more familiar. A smart city is an urban area that uses many technologies, especially the Internet of Things sensors, to collect data from the citizens, from the devices, buildings, or assessed. Then process this data and use this data to monitor and manage traffic and transportation problems, power plants, utilities, water supply networks, schools, libraries, hospitals, and all of the other community services. Smart city model is based on 6 smart axes, which are defined as governance, people, economy, environment, living, and mobility. The smart city model moves along 6 axes, and each them contains different parameters for the evaluation of the smartness of the cities. And since the university campuses mimics the cities in many respects, where there is a different users, students, employees, visitors, who carry out their daily activities, and where there are multifunctional buildings used for the execution of the several tasks. And in addition, universities and the cities have comparable issues and the challenges, such as about the environmental impact, management and the organization problems, internal and external mobility and infrastructures, and about the energy costs, crowding, and the connection to the connections and accesses to the campus. So for all these reasons, the smart city model is suited to be transformed to the smart campus model. This is also a good solution to face the challenges, to face the issues, to apply the smart concept to the university campus, to create the idea of smart campus concept. And smart campus actually is an emerging trend, enables educational institutions to combine with the smart technologies with its physical infrastructures for better services, improved decision-making activities, or increased campus sustainability, etc. And the university campus is indeed a small independency, actually, with several aspects such as the multiplicity of the functions, users, activities, and the connections. So under the umbrella of smart campus concept, many solutions have been implemented on campus levels, such as smart microgrid, smart classroom, controlling visual and thermal properties of the buildings, or taking student attendance through face recognition, or the smart cards applications. And the technologies identified for the smart campus include RFID, Internet of Things, cloud computing, 3D visualization technology, especially sensor technologies, mobile technologies, and the web services. So the smart campus is work to realize the multi-purposes, uses such an integrated environment, learning and living based on these technologies. So the concept of smart university is defined like a small world where many sensors enabled and network devices work continuously in collaboration to make the environment more smart. So the 6 axes, as we mentioned before, for the smart cities have been used as the baseline for planning and categorizing the suitable applications, suitable interventions for the smart campus application, and can be adapted to the universities. And following these guidelines, the smart concept can be integrated and overlap to the campuses in creating the smart campus concept. So when we look at the relevant literature about the smart campus applications, because of the smart campus concept is a relatively new concept, we can say that there are not so many papers about the smart campus applications. There are many papers about the smart city concept, smart city applications, but not much for smart campus applications until now. Many of the papers are about the technologies that can be adopted for smart campus concept. Just a few papers to evaluate the smartness of the campuses or evaluating the strategies to be smart by the universities. And besides, there are only limited number of papers with the application of decision-making methodologies among the paper that we review. So the outstanding papers are summarized in the current presentation. Especially, there are two papers in the presentation are related to the background of our paper. Use the 6-axis that we mentioned before for identifying and choosing the strategies to create a smart campus model, which are applied by the first writer on the slide, Mattoni et al. In 2016, and the last researcher, Pagliaro et al. At 2016 again. But they did not conduct a detailed analysis for the decision-making process as we do in this study. So apart from all these papers, we are applying a detailed analysis for evaluating the 6 smart axes, which are the key factors, as we can say, for the smart campus concept. So the aim of our paper is to prioritize the access of the smart campus concept. This is actually a preliminary study. For this purpose, we conducted an evaluation study to determine the importance level of 6 axes, which are governance, people, economy, environment, life, and mobility criteria, in determining the actions and strategies to be implemented in smart campus applications. The evaluation process for the criteria was handled within the scope of multi-criteria decision-making analysis. This analysis helps to evaluate the multiple conflicting criteria in decision-making processes. And in this context, we applied AHP analytic hierarchy process method. One of the most used multi-criteria decision-making methods was applied to determine the importance of the criteria. Also, we utilized from fuzzy logic to convert the linguistic variables into numerical expressions to be used in the calculations. We even applied to the intuitionistic fuzzy sets, which is one of the extended version of the regular fuzzy sets, to reflect the uncertainties in the linguistic expressions better. I don't want to go into detail about the steps of the methodology. I want to mention about shortly about the AHP methodology. AHP methodology, which is a popular multi-criteria decision-making methodology, performs pairwise comparisons of the criteria and determine the importance of the ways in the decision-making problems. In the literature, AHP method has been applied by combining with many different fuzzy set extensions to better cope with the uncertainty. Intuitionistic fuzzy set is one of the extensions that AHP method applied with, and this kind of fuzzy sets facilitate the better utilization of the linguistic terms in the decision-making environments by allowing us to assign both membership and non-membership values for the linguistic variables. And the application part, what did we do? We try to evaluate the key factors, which are the 6 axes for smart campus applications, to determine the importance of them in the decision-making processes, for sketching smart campus models or assessing strategies for smart campuses. And to evaluate these key factors, we consulted to the expert opinions via using the linguistic scale, as you can see on the table below. And we determined 5 experts from industry and the academia as the decision makers to evaluate the factors. And we sent surveys them to compare the factors with using the linguistic terms, as you can see in the table. So these are the evaluations made by the decision makers with using the linguistic scale that we presented in the previous slide. After we get the evaluations, we analyze the survey results to ensure the evaluations are consistent. So we apply to the consistency analysis and calculate the consistency ratios for each pairwise comparison matrix by the experts. If the consistency ratio is lower than 0.1, that means we can use the evaluations made by the experts in the calculations to determine the criteria weights. And if there is a ratio, then has a value greater than 0.1, and the survey was sent back to the experts and asked to re-evaluate the factors. And this step is repeated until all the calculations are consistent, and you can see the consistency ratios below 0.1 for each decision makers pairwise comparisons. And after we calculate the consistency ratios, we conducted the step of the proposed methodology for each pairwise comparison matrix and calculated the criteria weights for each decision maker. Then we aggregated the criteria weights calculated for each decision maker and found the final weights for the 6 axes. According to the results, we can say that the most important axis for the smart campus application is people, then economy, and the least important one determined as the life axis. In other words, this means that the most important criterion is evaluating the campus's smartness is people, while the least important criteria is the life criteria. When we analyze the results, we can say that it can seem that there is no big differences between the criteria varies. So this shows that all the criteria are important and effective of the decision-making processes. So what did we do in this study? We carry out a prioritizing analysis for the 6 smart axes, which are the evaluation criteria used in the smart campus application. This is an actually initial analysis for a detailed decision maker applications for the smart campus concepts or the strategies. With the criteria weight that we calculated here, decision-making problems with a complex hierarchy related to the smart campus application can be solved, as we said, for determining the smartness level of the campuses or the smart campus strategies. For future research, we can say that the extended version of this study can be conducted as we exemplified in the previous slide, or a comparative analysis can be performed by applying to the different quasi sets extensions. This is actually an example how our study can be extended. The factors seen in here, the criteria set, under the roof of six smart axes to evaluate the smart cities by Giffinger et al. And these criteria can be adapted to the smart campus application and used in decision-making analysis as we do in the future. So in our study, the determination of the weights of the main criteria, which is the initial step for a detailed analysis, detailed study was realized. Our plan is to extend this study for the smart campus applications. So thank you for listening.
Thank you for a nice talk. Is there any question? I guess there is no question. Next present, thank you again, dear Melih.
Thank you.
The next presenter is Kamran Zakaria. Kamran Zakaria is here.
Yes, I am hearing.
Okay. Title of his speech is Regionalization of Precipitation Zones by GWPS. If you are ready, we can start. Please share your screen, Dr. Kamran. Can you hear me?
Yes, I am hearing.
Please share your screen. And you can start if you want.
İlk hocam, kamerayı da açabiliyorsa söylerseniz.
Please open your video.
May I start?
Yes, you can start and please your video.
Yes. Bismillahirrahmanirrahim. My research topic is regionalization of precipitation zones by global wavelet power spectrum. My name is Kamran Zakaria. I belongs to the mathematics department, NED University, Karachi, Pakistan. My co-authors are Saima Mir and Saeed Hafiz. Both are research scholars in mathematics department, NED University, Karachi, Pakistan. Yes. The background is due to Pakistan economic development, the demand for water in the country is continuously increasing, which create uncontrolled and immeasurable economic, political, and social issues. The population and economy are heavily dependent on annual influx into the Indus River system, includes the Indus, Jhelum, Chenab, Ravi, Beas, and Satluj rivers. So our background, my background of study is to better ways to find out to control the water flows in as agriculture point of view as well as dam designing point of view. So Pakistan regionalization of precipitation zone. Here you see Pakistan. This is a map of Pakistan. Here, so we may divide that map into different regions. We divide that regions in 5 different regions according to climate and summer, monsoon. Research study across the country to observe the rainfall variations in different zones of Pakistan for the 30 years from 1976 to 2005. Researcher observed 30 stations from all over Pakistan. Furthermore, to check the variance, they divided the whole country into 5 zones as Zone A, B, C, D, and E. To analyze the variation in precipitation zones, they applied the analysis of variation ANOVA. But in this study, current study, we apply new technique that is called wavelet technique on research on river Indus Basin. Researcher observed precipitation trends annually, seasonal, and monthly across the Swat River Basin in 51 years across a time period from 1961 to 2011 by using all test and experiments row test. So different statisticians and mathematicians applying here different techniques. But in this study, the novelty in this study is we are applying here the wavelet technique on reverse Indus basin, since it didn't apply in past. So previously, wavelet power spectra is not applied on Indus River basin. So what is wavelet? Uh, Wavelet is just like wavelet is nothing but just like a Fourier transformation. Similarly, we may apply wavelet transformation on time series data to uh, make the groups of different frequencies. So the main aim of conducting this research is to hydrologically analyze the whole region of Pakistan to identify the precipitation zone around the map, to find similarity regions, the variability of rainfall on daily and on monthly basis. So here we apply that wavelet technique. There are several transformations that can be applied, but wavelet transformation is used because it transforms a one-dimensional time series into two-dimensional time and frequency simultaneously. The global wavelet power spectra works on non-stationary data of time and frequency series. Wavelet power spectrum is simple and robust way to characterize the time series variability of Indus River basin. Right? So first, in this study, we collect data from 56 meteorological stations of Pakistan, and on each end, that data is about around 30 to 40 years data. Duration of that data is 30 to 40 years data, uh, and we apply on that data that wavelet technique, and that data is highly non-stationary data. Each and every station we apply wavelet technique there, and we for each and every station 56 station. So here is one of the example I give here, because we have 56 station data, so it is not appropriate to display here in this short period of time. So here first I plot here, you see that is raining millimeter in 100 of millimeters, and this is time starting from 1970s to 2016. This is a plot of raining data. This is a in 100 millimeters data, and it is raining wavelet power spectrum. Where wavelet power spectrum here it is square of wave, because the frequencies are complex. So in order to find out better waves, so we may find the absolute values of these frequencies and plot here. That is called wavelet power spectrum. You see here, that is called wavelet power spectrum. And from 8 to 16, these are months, different months. So each and every year from August to April. This showing 8 means August month, August, and 16 means April. So it has each and every year of from starting from August to April. There is there was heavy rain. Here you see there is so this is one peak. This peak is showing us in this period of time there is very heavy rain there. This is variance, average variance over 2 to 50 years time series data here, right? So in this, so we divide this Pakistan into 5 regions. That is region 1, region 2, region 3, region 4, region 5. So region 1, it comprises those stations having cold climate and high mountains situated in the north of Pakistan. These stations are Chitral, Gilgit, Panji, Darosh, Balakot, Murree, Gari Dupatta, Muzaffarabad as given the reference. Region 2, this region has mild cold climate and sub-mountain located stations are Sialkot, Riai Khan, Islamabad, Pindi, Sargoda, Kotli, Faisalabad, Jhelum, Peshawar, Chirat, and Lahore. These are region 2. So this region 3 climate is cold in winter and hot in summer. Most of them are mountainous stations. Stations included in this zone are Quetta, Zob, Kalat, and Khuzda. Region 4 is the hottest and dry zone of the country where highest maximum temperature are recorded in stations of Sibbi and Jacobabad. Station included are Sibbi, Jacobabad, Bhawalpur, Kanpur, Parkha, Bawalnagar and Multan. Region 5 is a big zone having many stations and coastal cities near Arabian Sea. The selected stations from this region are Hyderabad, Karachi, Nawabshah, Nukandi, Dalbadin, Punjgar, Shore, Bela, Padijan, Urmara, Pasni, Gawadar, Badin, and Jivan. So by using this different climate, hot climate, winter climate, dry zone, hottest zone, based on these variables, we divide this Pakistan into 5 regions as given in the reference. We apply on these regions, we apply the wavelet technique on these 5 regions and find out where the rain is very high and the amount of rain is very high and the amount of rain is very low. Are you hearing me? The whole country is regionalized on the basis of precipitations, right? So pattern A shows high intensity of precipitation and pattern B shows rarely no precipitation. So identify the catchment areas where dams and reservoirs will constructed in future. Here we plot this is Pakistan plot map. Here you see, yes. Are you listening me?
Yes, we are listening to you, but we cannot see your screen. So please share your screen again, please.
Okay.
I think your wire contact is weak.
Okay.
Okay, it is all right.
Yes.
So actually we apply that wavelet techniques on 56 stations, and we we have found 2 types of pattern. Pattern A shows high intensity of precipitation weather like this. You see in this diagram, you see here that is a very high intensity precipitation zone here that is called Chitral, and similarly some region, some stations where we couldn't find such type of high frequency here. So we plot this 56 find out 56 plots of different frequencies, and we divide these plots into 2 patterns. Pattern A shows high intensity of precipitation weather, and pattern B shows rarely or no precipitation, right? So we plot here, you see on that diagram, we have 5 regions as given in the reference. These are five different regions of Pakistan, depend on cold weather, hot weather, dry weather, and different. Here you see 2 type of pattern. One is dark black square, small dark black square, and small and blank square. Yes, here you see that is called pattern A. So pattern A means where heavy rains there, and in pattern B also there exists heavy rains. In pattern 4 heavy rains also there, but in pattern 3 there does not exist any type of rain in pattern 3, and in pattern 5 there also does not exist any type of rain here. So we apply a mathematical technique called wavelet transform, and we find we have found these 3 regions where we locate the places for dam designing or better water management for agriculture point of view or for economical point of view. So we find out these different regions. Region number 1, it is better for planning of dam designing, for planning of water management, for planning of agriculture watering. That is good. zone, first zone is very good because rain is always there throughout the year. It is also better second region. Here you see two dark portion pattern A there exists here, but in 4 there also exists pattern 4 here, pattern A, but in 3 and 5 there does not exist any type of patterns here. Conclusion. Are you listening me?
Yes, we are listening to you.
Yes. This is conclusion. The main aim of conducting this research is to hydrological regionalization to analyze the Indus Basin of Pakistan. The effect of precipitation of 5 different regions will be examined. In the above diagram, it is mentioned clearly that region 1, 2, and 4 are strong frequency pattern, and remaining regions 3, 5 are weak frequency pattern. So it is possible to conclude that the wavelet transform is an effective tool in the hydrological regionalization process for the river Indus Basin, Pakistan. These are the references. Thank you.
Thank you for interesting talk, Dr. Kamran. Is there any question? I think there is no question. Thank you again. And
You are welcome. You are welcome.
Thank you all of you for valuable contributions to our conference. And we will send you certificate of participant after the conference. And now we will end this session. Thank you again.
Okay. Thank you.
İlk hocam.